Kathy T asks, the gravitational force F between an object and the Earth is inversely proportional to the square of the distance from the object to the center of the Earth. If an astronaut weighs 215 pounds on the surface of the Earth, what will this astronaut weigh 400 miles above the Earth? Assume the radius of the Earth is 4,000 miles. What we are told by this first clause of this question is that we have a gravitational force F, which is inversely proportional to the square of the distance from the object to the center of the Earth. Now that's a bit of a mouthful, but it's useful to know this symbol, which is the proportionality symbol, and the inverse of anything is 1 over that thing. And we know it's inverse to the square of the distance from the object to the center of the Earth. So let's call that the radius of that object relative to the center of the Earth, so r squared, because it is the square. So we find this proportionality equation here. In order to convert this proportionality symbol to an equals sign, what we have to do is add a proportionality constant to this equation. And the reason for this is because when we have a proportionality equation, we can turn that into an exact equation with a constant of the same order as the lowest order in that equation, because to say something is proportional is to say that it is related to that by a constant that doesn't have an exponent. Because if it had an exponent, that would throw off the proportionality. So we know that there's some constant which has an order of 1, that if we multiply it by this proportion, is equal to the force. And the force in this case is just the weight of the astronaut, 215 pounds. If we rearrange this equation to find the proportionality constant, we're going to be able to plug in a new radius and find a new force. So let's find that constant k. K is going to be equal to, right, we're going to multiply by r squared. It's going to be F times r squared, which in our case is going to be 215. And I'm just going to type this out because it's going to be a bit neater. 215, which is our force, multiplied by the radius of the Earth squared, which is going to be 4,000 to the power of 2, 4,000 squared. What we will find if we use a calculator to calculate that value is the number, and it's a fairly large number, so I'm just going to use scientific notation. It's 3.44 times 10 to the power of, well, I'm going to do it like this for ease of reading, times 10 to the power of 1, 2, 3, 4, 5, 6, 7, 8, 9, times 10 to the power of 9. So we have this proportionality constant k. This is equal to k. Now we can use this with our rearranged formula, and I'm going to type that formula here, that F is equal to k, which is this 3.44 times 10 to the power of 9, multiplied by one over the new radius of Earth squared, which is 4,400 miles. And that equation is going to give us our new weight of the astronaut. So let's plug that into our calculator and see what we find. 3.44 times 10 to the 9 multiplied by 1 over 4,400 squared. And we find that the new weight of our astronaut is equal to 168.6859 pounds. So let's just say 0.7 pounds. It doesn't say what to round to, but I think that's precise enough.